hypothesis test for population mean standard deviations known. And when we talk about standard deviation knowns, we're talking about population standard deviation. Okay, requirements. Samples obtained using a simple random sampling or from a randomized experiment. Sample has no outliers, and population from which sample is drawn is normally distributed, or the sample size n is large. N is greater than or equal to 30. And the sample values are independent of each other. Now, this first part talks about the critical value method, and we're going to skip over that. This video is specifically focusing on the p-value approach using TI3, TI84. So let's go down to that. Now, this note here, the p-value is the probability, assuming that h0 is true, of observing a value for the test statistic that is extreme as or more extreme than the value actually observed. The smaller the p-value, the stronger the evidence against h0. The p-value approach has an additional benefit on it. Depending upon what the value of the p-value is, then it'll either support h0 or be against it. So this right here is saying a smaller p-value, the stronger the evidence against h0. So if you have 0.000001 for your p-value, then that tells you that evidence is really against h0. If your p-value is high, like 0.9, then that goes the other direction. So it gives you a little bit more meaningful results in like the classical approach or the critical value method. Now here's how we're going to do the p-value approach on TI3, TI84. We write down a shortened version of the claim. We come up with a null and alternate hypothesis. h0 always has equals part on it. Then we'll see if our claim matches h0 or h1. We'll find a p-value using a z-test. And then if p-value is less than alpha, we'll reject h0. If p-value is greater than alpha, we'll accept h0. And then we'll determine the claim based on step 3. Now let's skip down here to our problems. And this is an important note. Practical significance refers to the idea while small differences between the statistic and parameter stated in null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. I did a claim one time where I was checking the percentage of students who successfully finished a course, and I was comparing it between two different instructors. And it looked like, statistically, that this one instructor was greater than another instructor. You know, that the results were significantly greater than. But when I actually looked at the actual numbers, I think it was a difference of like the instructor that did better got 3 additional students through their course more than the other instructor. Well, 3 students is not really, from a practical standpoint, significant. So statistically, the claim said it was, but then when you start looking at the numbers, it really did not make that much of a difference. So you have to be careful when you're throwing claims around and you're saying, well, yeah, this instructor is doing much better than this one, or this company is doing much better than this one. You know, is it really? Okay, I'm going to start this problem again. I started this before, and well, I didn't have population in there, so I had to redo the problem. So try 2 at the video. I actually tried 3, but I had some problems last night. Hopefully this try will get through, though. Okay, number 1. It says, if I can get back there, the mean amount of fluid in a bottle of lens cleaner is 59 milliliters. It says the mean, which we're talking about mu. That's probably our old mu. We think maybe it's changed since then. Population mean. A researcher believes the claim is actually lower than that. That sounds like our claim. So lower than 59. 15 bottles are sampled, so that'll be N. N is 15. And the mean is found to be 58, so X bar is 58, with a population standard deviation of 1.2. So sigma is 1.2. Test claim based on this information that alpha is equal to 5%, assume it is normally distributed. Okay. Now look back to our title. Hypothesis test for population mean. Standard deviation is known. Okay, it's talking about the mean, and specifically we're given sigma. That's what triggers us that we should be in this section. Okay, so let's look at our steps then. P-value approach using TI83, TI84. Step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. Lower than, that's this symbol right here, less than. So this here is going to be mu is less than 59. The only symbols you can put on H1 are less than, greater than, and not equal to. That's why I put the less than here. Well, these are opposites of each other, so if this is less than, then we're going to put a greater than or equal to here. Now this is the technique that I learned way back when, whether these are exact opposites of each other. The new trend in books is that this is always an equals on your H naught. So keep that in mind if you're looking at your book. I'm happy either way that you want to do it. Okay, step 3. See if your claim matches H naught or H1. Well, here's a less than, and our less than was on H1, so our claim matches H1. Now it says we're going to find a p-value using a z-test. So let's go do the z-test. Okay, so on our calculator, we're going to press stat. We'll go over to tests, so right arrow over to test, and we'll choose z-test. And it's the first one, so I'll press enter on it. Now we got data and we got stats. Data is when you're given raw data. Well, we're given summary statistics here, so we want stats. So I want to right arrow over and press enter on stats. And then I'll down arrow. Now mu naught is always a number that's off of your claim, H naught, H1, whichever one you want to pick. So that's 59. Sigma. Sigma we said was 0.05. X bar we said was 58. And N we said was 15. Now this next one is the symbol off of H1. Well, H1 is a less than, so we want to right arrow over to the less than and press enter on it. Then I'll down arrow to calculate and I press enter. And we get P is equal to 0. I didn't put in the right, try it again. Stat, test, z-test. My eyes are bad. 0.05, that didn't sound right when I put it in. 1.2, I was looking at the wrong line. Okay, 1.2. Now let's down arrow and choose calculate. Okay. Got P is equal to 6.2445. 6.244. Actually 8. 6.2448. Okay. Now normally we take it to 4 decimal places, and I went ahead and took it to 4 here, but this is scientific notation. That e to the negative 4 means I moved my decimal place 4 places to the left. So I got 0.0006. So once we get it out of that form, I mean, I wouldn't do much rounding until you get it out of that form. Then this is our p-value. Let's see what that means. It says if p-value is less than alpha. Pretty small p-value, and alpha is 0.05, so it is less than it. It says then we reject H naught. So for a conclusion, we reject H naught, which means we accept H1. And this says determine the claim based on step 3. Well, step 3 we said the claim matches H1, so whatever we say about H1 is what we say about the claim. So we'll accept the claim that the mean is now lower than 59. The word accept is usually not used in books. They like to use do not reject. Accept is a pretty strong word, and I find students click better though if I use reject and accept. Do not reject kind of throws them. Well, why is this true? Obviously it's smaller. We got 58, and this is 59. But if you look at our standard deviation makes a big difference on that. Now this is a pretty small p-value anyway, but remember when I put in 0.05 by mistake? It was actually a good mistake because we got a p-value of 0. So you can see that going from 1.2 to 0.05 made a significant change in the p-value. And along the same lines, if I change this to 2.3, then we might see even more strange results like that. Okay, let's look at another problem. Problem number 2. It says the mean amount of fluid in a bottle of lens cleaner is 59. So they're telling us mu is 59. Researcher believes that the mean is different than that. That sounds like our claim. So we think mean is different than 59. 35 bottles are sampled, so n's 35. And the mean is found to be 63. So that's x bar, because it's referring to the sample. With a population standard deviation of 2.3. So sigma is 2.3. Test a claim based on this information that alpha is equal to 0.01. Okay, let's go up to our steps. Step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. H naught always has equals part on it. Okay, so this is mu. Now different than. Different than is the not equal to, and that's going to go on H1. So that's going to be, say, different than 59. Now the only symbols you can put on H1 are less than, greater than, or not equal to. The only symbols that can go on H naught are less than or equal to, greater than or equal to, or equal to. Now these are opposites of each other, so if this is not equal to, this will be equal to. Now I show this where you can put either one of these three symbols on H naught, but a lot of books have adopted the convention again of only putting equals here. Not that it matters for this example. Step 3. See if your claim matches H naught or H1. Not equal to up here, not equal to down here, so our claim obviously matches H1. Then it says find the p-value using the z-test. So let's go do the z-test. Hopefully I can type it in correctly this time. Okay, so I'm going to go do my stat, go over to tests, do enter on z-test. We're given summary statistics again, so that should still be highlighted. Down arrow, mu naught is a number off of your claim H naught H1, which is still 59. Sigma is 2.3. X bar was 63. And N was 35. Now this next one is a symbol off of H1, which was a not equal to. So I press enter on not equal to, and down arrow and choose calculate. Very, very small p-value here. I think it's 4 decimal places initially. It's got 8.813 e to the negative 25. E to the negative 25. Which means I move my decimal place 25 places left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 8. And you know, I could take it out to these more decimal places, but I think it's pretty obvious what it is. And now the question is, did I screw up? So let's go take a look. Do my stat, go my test, z-test. I'm going to check my numbers. 59, 2.3, 63, 35. Okay. Why is it so small? Different than 59. Look what we came up with, 63. That's a difference of 4. And if I think of my standard deviation, which is roughly about 2, that's like 2 standard deviations away. So it's definitely much different than 59. If I go back to my steps, if p-value is less than alpha, obviously p-value is less than alpha, alpha is 0.01, then it says we'll reject H naught. Now H naught and H1 are opposites of each other, so if I reject H naught, that means I'll accept H1. And our claim matches H1, so whatever we say about H1 is what we say about our claim, so we accept our claim. Now it's more than just accepting it. Realizing how small this p-value is helps us to realize the weight of the acceptance. You know, it's much different. And when we look at the standard deviation, you can kind of see that. But the p-value, again, really helps point that out. If I had come up with 0.009, would have been less than it, but it's really close to your alpha. So, you know, then we couldn't say, well, it's not quite as severe in terms of the difference. Okay, one more. And we go down to the last problem. I don't know how this one will turn out because I just made the standard deviation up out of my head. So we'll see. See, the mean amount of fluid in a bottle of pop is 16.9. So they're telling us that the old mean is 16.9. It's mu population mean because it doesn't refer to a sample at all. Okay. Researcher believes that the mean is more than that. Yeah, that sounds like a claim. So mean more than 16.9. And 10 bottles are sampled, so that's N is 10. Test a claim based on this information that alpha is equal to 10%. So alpha is 10%. Assume it is normally distributed and population standard deviation is 0.5. So sigma is 0.5. Now the sigma is what I made up here, so we'll see. Well, I got raw data, and I know eventually I'm going to need to have that in my calculator, so let me go put it in. So I'll do a second mode to exit out, go into stat, into edit, and I'll clear out L1. Okay, so we got 16, 16.1, 17, 17.5, 17.2, 17, 17.5, 16.3, 16.7, and 18.7. And let me double check my numbers. 18.7, 16.7, 16.3, 17.5, 17, 17.2, 17.5, 17, 16.1, and 16. Exit out. And now we're going to go through our steps. Okay, p-value approach, TI83, TI84. Step 1, write down a shortened version of the claim. We did that. Step 2, come up with our null and alternate hypothesis. Now, more than, that's the greater than. So for our alternate hypothesis, we'll put the greater than there. Again, the only symbols you can put on H1 are less than, greater than, or not equal to. Only symbols you can put on H naught are less than or equal to, greater than equal to, or equal to. Well, these are opposites of each other. So if this is greater than, this will be a less than or equal to. Again, books like to put equals here anymore. Our claim matches H1. So now we want to go in and do our z-test and find our p-value. And we'll see what my just making numbers up gives us. It's not always good, but... Okay, so I'm going to go into my stat, go over to test, and choose z-test. This time we're given raw data, so I want to left arrow over and press enter on data. Down arrow mu naught is 16.9. Sigma was 0.5. Your list we put into L1, so you should say L1. If it doesn't, do second 1, and that'll put L1 there for you. Frequency should say 1. If it doesn't say 1, press your alpha to turn off your alpha lock and then do 1. Now the symbol on H1 is a greater than. So I want to right arrow over to the greater than and press enter on it. And down arrow to calculate and press enter. That's a decent p-value. I guess I did a pretty good job of guessing on this time. 0.26. If I can find my mouse, there it is. Okay. 0.2635. There's no scientific notation there. That is actually our p-value. P-value is less than alpha. Definitely not less than alpha. Alpha's 10%. So if p-value is greater than alpha, well, it's greater than alpha, so it says we're going to accept H naught. And if we accept H naught, that means we're going to reject H1. And since the claim matches H1, whatever we say about the H1 is what we say about the claim. So that means we'll reject our claim. And if you look at your data, claim is the mean is more than 16.9. And you see you got 17, 17.5, 17.2. There's a lot of them greater than 16.9. But again, given the standard deviation there, they're not significantly, statistically significant greater than that value. And that's the p-value approach by claims about means where population standard deviation is unknown.